All right. If you are asked to multiply, so we talked about distributing when it's a monomial times a binomial, using FOIL when it's a binomial times a binomial, which again is just distributing, and then we have any of those special product forms. Anytime you see two trinomials being multiplied, you have two choices. One, you could distribute. Again, this works for all products. So if you distributed, you could take your first term, distribute that through. So we would get an x squared here plus a 3x here plus an xy. Move to your second term, we get a 3x. So I'm going to put it under this same like term. Plus 9. I'm going to build or start a new column. And then plus 3y, new column. And then our last term here is minus xy. I'm going to write it in the like column. Minus 3y, again in the like column. And then minus y squared. And so when I combine these, I see that there's several terms that cancel. I get an x squared plus 3x plus 9 minus y squared. When you come up with your final answer, when you write your answer in the homework, what I want you to pay attention to is the degrees of the individual terms. Oops, this is a 6x. Is that what you're going to tell me? Thank you. Hey, when you reorder these terms, what you need to do is put them in from highest power to lowest, and if there's multiple terms with the same degree, write them in alphabetical order. So x squared and y squared both have a degree of 2. I'm going to write the x squared first, followed by the y squared, then our term with the first degree, and then our constant. And so this is the order that I would write these terms in my answer.
When you have like a different like variable or whatever, how do you know which one to like put first?
Just
like,
alphabetical.
oh.
Yeah. So I mean, if xy had remained a term in here too, you would write it as like an x squared, followed by your xy's, followed by your y squareds. So anything that contains the earlier letter will go first. Now, there's no right or wrong way to put it. This is just eliminates me having to put in every possible combination of letters. So I just want it to be some kind of system to do it. If on a quiz or a test you put, like if you were to enter this on a quiz or a test and it didn't show up as right, that would definitely be one. I'd just add it to the list and slowly build it up to all the possible combinations. All right, now, in addition to distributing, the other thing that you can do anytime you see trinomials is look for unique grouping patterns. That would create a special product form. Okay, so if you looked at this problem right here, what you might be able to see is if you grouped these first two terms together. So if I grouped x plus 3's together, really what you wind up with is you wind up with this form of a minus b times a plus b. We created this sum and difference pattern, sum and difference of terms pattern, and we know that the special product form for that is the difference of squares, a squared minus b squared. So if you see that, if you're able to find that unique grouping method to create a special product form, what you can now do is just go straight to your expansion. It's the first term squared. Well, my first term was this binomial x plus 3 squared minus my second term squared, which was y's. And then you can just, again, apply your special product form here. Square the first term, double the product of the terms. So x times 3 is 3x. Double that, you get 6x. Square the last term, plus 9 minus our y squared. And what you see is this winds up giving us the exact same answer. It's a little more efficient if you can see it, right? But you can choose either of those methods, either distribute or look to group.